My name is Matt Brown. I'm here to talk to you about my research on mental illness. So diseases like schizophrenia and depression, these cause people to suffer. They cause their families to suffer. These people shouldn't have to suffer, so that's why I do this research. Mental illnesses also impose huge costs to society. By one estimate, in 2003, mental illness as a whole cost Canada $51 billion in direct and indirect costs. Now, treatment for mental illness is a challenging field. The fundamentals of these diseases are not completely understood. Different people react differently to treatment, so what works for one person may not work for the next. Often there is some degree of trial and error during treatment whereby somebody will try different treatments until hopefully arriving at something that works for them. But that can be a long and often frustrating process. Treatment for mental illness in terms of the diagnosis and the prognosis, these are based on clinical interviews and behavioral observations. In neurology, which also deals with brain diseases, practitioners have the benefit of MRI brain imaging to assist with the diagnosis, so they can look at brain structure and lesions and so on can help with the diagnosis. Nothing like that exists for psychiatry at the moment, but this is something we're trying to change. So in my work, I use a form of brain imaging, functional magnetic resonance imaging, or fMRI. I'm sure you've all seen MRI pictures on TV that show brain structure. fMRI gives us a measure of dynamic brain activation that occurs as thought processes unfold. Now, fMRI data is complex and large. If you scan one person, you typically get tens of millions of data points. So to deal with all that, we use advanced machine learning algorithms. Machine learning is just another name for artificial intelligence. You feed the data into these algorithms and they chew through the data looking for useful or interesting patterns. One advantage of using machine learning is that these algorithms can often pick up on subtle patterns in the data that a human scientist looking at that same data would miss. So to bring this all together, what we do is we take fMRI brain scanning and we combine it with machine learning analysis, and we're trying to deliver new clinical tools for diagnosis and prognosis. There are some early encouraging successes in this area. So, for example, based on somebody's fMRI scan, it's possible to diagnose whether they have schizophrenia or depression or bipolar disorder with accuracies on the order of 80 to 90%. This field is now moving into the next stage of research. We want to do prognosis. That is, we want to predict who's going to do well or not with treatment. We want to predict which treatment will be best for a given person. And this particular work is in the early stages, but it shows real potential to provide new clinical tools for practitioners so that they can provide treatment that is faster and more effective. And one last thing I want to say, I mentioned that these machine learning algorithms can often pick up on things that people miss. So this approach of combining fMRI with machine learning also has the potential to provide new insights into mental illness. So new conceptualizations, new ways of thinking about these diseases. And I'm happy to talk about that further with anyone who's interested. Thanks for listening.